Hello everyone. Yeah, this moment I want to share again about other physics question solution. Yeah. Yes, this is about energy change in similar harmonic motion. But before we continuing, please don't forget to subscribe my YouTube channel and please push the button of notification. So, yeah. Okay, let me start about number one. We have four numbers here. Yeah. You can see here first and you can read first. Maybe you want to read first. Yeah, yes, please 2 minutes to read first. Okay, yes, number one, yeah, particle is oscillating in simple harmonic motion with period t as 4.5 millisecond, millisecond. This millisecond, something with 4.5 times 10 minus 3 second, and amplitude A as 3.0 centimeter. If we change into meter, yeah, times 10 minus 2 in meter. And at the time t, the particle is at the equilibrium position. Calculate for this particle A, B, C, D, E. Yeah, we have 5 questions in number one. Yeah, let's try to solve this question. First question is frequency. Yes, frequency, we have formula for the frequency as the 1 over t. Yeah, so F means yes 4.5 times minus 3. Yeah, this is same with, yes, actually 10 power 3 divided by 4.5. Yeah, 1000 divided 4.5. 1000 divided by, yes, we have 222, yeah, hertz. Yes. Okay, now big question. On the big question, yeah, the angular frequency, yeah, angular frequency is omega, and the formula is 2 pi f. Yes, or 2 pi and f if, yes, this is, yeah, 444 pi, yeah, in radian per second. Okay, continue to see question. The maximum speed V max, V max same with a omega, yeah, amplitude times omega. Amplitude, we have 3, yeah, times 10 minus 2, and omega is 444 pi. Yeah, so yes, we calculate this number. Yeah, this is something with 3 times 4 point, yes, 13.33. Yeah, this is around 13.33 pi, yeah, meter per second. Also we can change pi in 3.14, yeah, but in term of pi is 13.33 in meter second. Okay, continue to the question. On the question, the magnitude of maxima acceleration acceleration maximum. this is something with omega square a. Yes, omega as the 444 pi square, and then amplitude is 3.0 times 10 minus 3. Yeah, we'll calculate this first. Yeah. 444 times 444 and times 3. Yes, 591. Yeah, okay. All right, this is around 0.591, yeah, pi square, yeah, in meter second square. You can also change pi into 3.14, yeah, 3.14, and this is in term of p, yeah, in term of pi. Okay, continue the last question on number 1. Yeah, E question. Yeah, the speed at the time 1 millisecond. We have formula V as the Vmax, yeah, cos theta, theta as the omega times t. Yeah. So if we include this number, yeah, Vmax, we have 13.33 pi. Yes, cos omega, we have omega is 444 pi, and t, we have t is 1 millisecond minus 3. Yes, so 13.33 pi, and we find about cos. Oh, yes, cos of this is 0.444 pi. Yeah, we need calculator. Yeah, I don't bring any calculator. Okay, you can use the calculator and find this is something actually 0.44 pi is, yes, I think cos of, let's say, yeah, around 90, or yes, around 80 maybe. Yeah, you find here, yeah, and then you get the number here, how much is. Sorry, we don't bring any calculator here. Okay, thank you for watching until number 1, and yeah, please don't forget to subscribe my YouTube channel. Yeah, and we will continue about number 2. Yeah. Okay, sorry. Yes, number 2. Yeah. A particle is oscillating in simple harmonic. Yeah. With frequency 50 Hz and amplitude 15 meter. Calculate the speed when the displacement for equilibrium position is 12 millimeter. Yes, actually we have for number 2, yeah, for the first is frequency, yes, 50 Hz, and amplitude, yes, 15 millimeter, and we have Y, yeah, as the 12 millimeter. Okay, the question is calculate the speed, yeah, V. V, yeah, as the A omega, yeah, cos theta. omega is 2 pi f. Yeah, omega is 2 pi f, and amplitude we have 15 millimeter. Yeah. And yeah, for this equation we still haven't about cos theta. We find from this that we know about a y equals to a sine theta. So from this, yeah, y is 12, yeah, and a is 15 equals to sine theta, or sine theta means 12.15. This is same thing with 5, correct? Yes. 4 divided 5, yeah. What cos? Yeah, you can find this is actually cos theta is 3 over 4, yeah, from this, yeah. And now we bring into this formula that a is 15 millimeter. Yeah, we change into meter, and 2 pi f, 2 pi, yeah, frequency is 15, and cos theta is 3 divided by 5. So yeah, let me check, yeah. 15 times with 2, let's say 2 times with 50, yes, so times 3 and divided by 5, 910 power minus 3. So yes, this is around 0.9 pi, yeah, 0.9 pi meter per second. Yes, this is the answer, yeah. Okay, thank you very much. You're watching until number 2 ends, yeah, and please subscribe my YouTube channel. Okay, we will continue to number 3. Yeah, you can see question first. I will take paper black. Don't forget to like my YouTube channel. Don't forget to give any comment if you have any something adopts something question or anything, yeah, give me a good feedback, yeah. Yes, almost sorry, yes. Number 3, yeah. Okay, let us read first here. Number 3, geologists use the fact that the period of oscillation, a simple pendulum, depends on acceleration of revolve to map variation of G. The geologist determines that the frequency of oscillation of the pendulum is of effective length 515.6 millimeter to be 0.69 for 8 hertz. Yeah. Calculate the acceleration of revolve at this locality. Yeah. Okay, we draw first about how we know here as frequency of oscillation. Oh, but this is about the y as the 505.6 millimeter, and they have frequency as 0.6948 hertz. Yeah, calculate the acceleration. Okay. we have the formula of the acceleration is omega square y. Yes, so we already have y, and we need to break down the omega into function with frequency. So this is actually omega is 2 pi f and square and times y. So okay, and negative 2 pi, frequency is 0.6948 square, and y is 515.6, but we need to change into meter times -3. So we calculate this number. I try to calculate with my calculator here. So 2 times let's say 0.6948. Yes, we have 1.38 pi square, and times with this is same thing with if 10 power minus 3, this is 0.5156. Okay, we double click times with 0.5156. Yes, this is around 0.716 times pi square. If we change pi into 3.14, so we can say this is times 3.14 times also 3, we get 7.0. This around 7.0 in meter second square, and also in negative. This is the direction of this pendulum is opposite. The direction of acceleration is opposite with the motion of this pendulum. Okay, thank you very much for watching my video until number 3 ends. Please don't forget to subscribe. Now click the button of subscribe, the red one, and click the notification. And also please give me a comment. Give me a comment if any feedback for me. There is some doubts or anything question you want to ask me, please give me a comment. Okay, we'll continue number 4. Take a read first. I give you around 1 minute. Yes. Okay, number 4. A spring stretched by 85 millimeter when mass of 5 gram is hang from it. The spring is then stretched further distance 15 millimeter from the equilibrium position, and the mass is released at time from 0. Calculate. We have A, B, C, D, the question. Okay, now better we draw first about the diagram. This is spring and attach mass here. This is mass is 50 gram. And I'll hang 80. Yes, let's see, this is 85 85 millimeter. the spring then stretch for the distance 15 millimeter, yeah, then yes, then yeah, 15 millimeter, strike down, yeah, from the equilibrium position, and the mass is released at time. Calculate A, yes, spring constant, yeah. Let's say we will try it in this area. Spring constant, yes, K means F the force over delta X, yeah. And F, this is about force on this condition. This is something with M times G as the weight, and divided X, delta X is 15 actually, yeah, delta X. So KS, we have 50 grams, something with 0.05 in kilogram, times gravity, let's say, oh, gravity is 9.8, sorry, 9.8, not 10, yeah, and divided by delta X is 15 millimeter, 15 millimeter in meter times minus 3, yeah. So we calculate this number. Sorry, I use the calculator first to calculate this number, yeah. 0.05 times 9.8, yeah, and divided by 15, yes, we have 0.032, but we have 10 power minus 3, so this is something with we yeah, something with times with 1000, yes, 32.67, yeah, let's say this is 32.67 in Newton meter, yes. Okay, finally we get about the question A answer is, yeah. Again, please don't forget to subscribe now, and we will continue about the B question is, yeah. On the B question, yeah, the amplitude of the oscillation, yes, because we strings 15 millimeter, this is actually 2 of amplitude, yeah. So it will be make a wave, yeah, with the 2 amplitude as the 15 millimeter. So one amplitude something with 7.5 millimeter, yes. Okay, and the period, well, the period, yeah, the period, we have the period, yeah, for C question, period same with, yeah, 2, yeah, pi root of, yes, K, yeah. So we have 2 pi, mass hanging on this pendulum is 50 gram or 0.05 in kilogram, and K as 32. With 32, yes, 0.67, yeah. We don't have any calculator here, we don't bring any calculator, so you can find this number and write this number and times with 2 pi, yeah, and this is in second. Okay, yes, the displacement time t after 0.2. Oh, okay, on the answer is, yeah, the displacement. Yeah. Yes, this is something a sine omega t. Yeah, a sine, this is 2 pi over period, yeah, times t. So we have amplitude here as the 7.5 in millimeter. Yeah, yeah. This is 7.5 minus 3 sine 2 pi t. We have t. Oh, this is the t is on the C question. Yeah, because we don't bring any calculator here, we can the root for this number. So after you get t and you calculate the and t small is 0.2. Yeah, you calculate here and then get how much theta is. Yeah, and change p into 180 degree. Yeah, on the p is 100 degree. Yeah, and blah blah blah, you can get the number of sine and then you calculate this by multiplication with this amplitude. Yeah. So we can find how much here is. Yeah, in, let's say, in minus 3 10 power minus 3 in meter, and this is same thing in millimeter. Okay, thank you very much for watching my video. Don't forget to subscribe my YouTube channel and give me a comment. Yeah, give me a comment on the below window, and see in other videos. You can click any videos in this channel. Thank you very much.